Welcome, welcome. We are going to be talking about angles and circles today. So we're going to start with something familiar that we've used in the length formula before, and that's called a central angle. Any angle that has a vertex on the center of the circle we call a central angle. And when it opens up to the arc it intercepts, the degree measure of the angle is equal to the degree measure of the arc. Arcs can be measured in three different ways. Arcs can be measured in length. If we're given the radius, we can figure out the length. But they also can simply be measured in degree. And that's what that little M with the little curve above it just is telling you. That means the measure of arc AB is equal to the measure of angle AOB. And so in this case, angle X would just be 82 degrees. So I simplify that and I say angle equals arc. We can have a few unique problems associated with these type of angles. So the first type of problems you might see would be pie charts. If you have a pie chart, usually we use pie charts as percentages, but they can be represented with degrees as well. One thing that you do have to remember is that all the degrees in a circle add to 360. So we can get all the missing degrees by adding whatever degrees are available and subtracting that sum from 360 to get the information here. So let's read the problem. In a recent poll, 600 people were asked whether they like Chinese food. A circle graph was constructed to show the results. The central angles for two of the three sectors are shown in the accompanying diagram. How many people had no opinion? Well, we got the likes and the dislikes. That's 160 degrees and 140 degrees. The no opinion, we don't know, but we can get that by subtracting these two values from 360. So if I do 360, subtract the 140 and the 160, or add these two together and subtract, that's going to give me 60 degrees. So now I have all the missing angle measures. Now what I want to do in this problem is I want to set up a multiplication problem where I'm basically taking my 600 people. Since I want to know how many people had no opinion, I'm looking to see essentially what percent of that 600 is going to have no opinion. Well, you can get that percent by taking your 60 degrees and divide it by 360. That's really just 1 out of 6. If you want to do it as a percent, then you can divide the two in your calculator. And that gives you about 0.16 repeating. Or if you want to do it as a reduced fraction, that would be 1/6. Either way, you're going to times that by 600 people. And, that's 1/6 of 600, or in other words, 600 divided by 6. And that gives us 100. So your answer is 100 people had no opinion. Similarly, you could do the same thing with the likes and the dislikes. Okay? With question 2, let's read the problem and see what it's asking. You're sewing the seam on a circular lampshade for interior design class. The total circumference of the lampshade, that's your C, is 3 feet. The amount of the seam you've sewn so far measures approximately 23 degrees around the circumference of the lampshade. Well, what is that 23 degrees and what does it represent? Let's picture this. If I have a circle and my circumference is 3, that 23 degrees represents a small portion of that arc, of that circumference. That 23 degrees might be, maybe that your central angle is 23 degrees, that's about the chunk of that arc that would be. So not a whole lot, but remember that's an arc measure, which is the same thing as the central angle. So this is a arc length problem. It says what length of lampshade still needs to be sewn. Remember the arc length formula is L equals 2 pi r times the degree of the central angle over 360. Remember that 2 pi r is also the circumference. So we are given the circumference, that's 3. So we're going to plug 3 in, and we're given the degree, that's 23 degrees over 360. So again, just kind of like what we did before, we're taking our degree and dividing by 360 and multiplying it by a value to get whatever length is here. So this arc length can be measured, or the arc can be measured in a degree, which would be 23, but as a length, that gives you about 0.19, and the units are in feet, so that's going to be 0.19 feet. And if you were asked to convert that to inches, which I would times that by 12, and that gives me 2.3 inches. But we don't have to do a unit conversion on this to get the answer right. 3 and 4 are kind of similar. They both have two equations you need to solve. On 3, I have a central angle, and I have an intercepted arc. And those two are equal, so you can solve for t by saying 2t minus 3 equals 9 minus 4t. So let's add the 4t onto the 2t. That's going to be 6t minus 3 equals 9. Add the 3. 6t equals 12. That's going to make t 12 divided by 6, so t will be 2. And so if you plug that 2 back in, that's going to be 2 times 2 is 4, minus 3 is 1. It doesn't look like it's drawn to scale, but 9 minus 4 times 2 is 9 minus 8, which is also 1. So your math checks out. You know, you're going to find t here the same way. The only difference in this problem is that you're given these chords over here. A chord is a segment that connects 2 points on a circle. Because these are the same length, that's going to imply that the degree that angle opens up in the center is going to be the same on this side. So even though this is drawn at this arc over here, I can tell you that arc and angle are equal. So your math is still going to say set them to equal to each other. So if 23 minus 2t equals 15 minus t. So let's check that out. That's going to make me want to add the 2t onto the negative t. So 23 equals 15 plus 3t. Now I want to subtract 15. So that's going to give me, let's see, 5, 6, 7, 8 equals 3t. Oh, you know what? I messed my sign up. So that's actually negative t plus 2t. So that's actually going to be 1t. So 8 equals 1t. That means t is going to be 8. Let's check that, plug that in since I had a little bit of a slip up. 15 minus 8 is 7. And 23 minus 2 times 8, that's 23 minus 16, was also 7. So it checks out, and 8 is going to be your answer. Number 5, it says in the diagram of circle O, chord AB is parallel to chord CD. Well, those are parallel. That's going to imply that if I open up a central angle on the right side as shown, I should get the same degree if I open it up over here. So these two are going to be congruent to each other. So AB is parallel to CD if the measure of arc AC is 100. Well, that means the central angle here is going to be 100. Again, that's not drawn to scale. That means this arc over here will be 100. And the central angle here is also going to be 100. And since they want to know the measure of angle BOD, which is this angle I'm outlining, that's also 100 degrees. And finally, on number 6, it says the circumference of the trunk of a tree to be decorated is 12 inches. You have 7 inches of garland to wrap partially around the tree trunk. What is the arc angle of the trunk that you will decorate? Well, I want to know the arc angle, which is equal to the central angle. And this is another length problem. So we can employ that equation again. L equals 2 pi r times degree over 360. Well, let's look at what we have. The circumference of the trunk of a tree to be decorated is 12 inches. That's your C, which is also 2 pi r. The 7 inches of garland to wrap partially around the tree trunk, well, that's going to be your length. Because if you have a tree trunk, and you know all the way around that is going to be 12, if you wrap some garland around that, and that's only going to give you 7 inches around, 7 represents your L. So this is going to be 7 equals 12, that's your circumference, times degree, over 360. 7 equals 12 times degree over 360. See if you can solve that on your own, and we'll check that. What I would prefer to do on this problem is multiply by the 360 and divide by 12. So 7 times 360 over 12 is equal to the degree. And we'll use our calculator to plug that in. So that's going to give you 210 degrees. So in other words, around the circle, 7 out of 12 is 210 degrees out of 360. So that concludes the central angle stuff. Watch the next video is going to talk about inscribed angles.